Now, this is the second video for 6-2, and for this section we're actually going to have 3 videos, so I'll have another one after this one. The learning target this time is similar, but it's going to have to do with radicals. Apply properties of radicals. Okay, so we did do these in Chapter 5 also, but let me write them out again. So if you have a product underneath the radical, you can break it apart into 2 separate radicals. And you can also do vice versa. If it's already broken apart, sometimes it's helpful to put them together under the radical to help you solve it. And the same thing happens if there's a fraction underneath the radical. Sometimes it's easier to solve the problem if you separate them. And oops, that's supposed to be an N right there. Sometimes it's better to put them back together. So let's do some examples. So if I have the 5th root of 27 times the 5th root of 9, neither one of these numbers are have a whole number answer. They would have decimal answers. So I'm going to try to put them together and see if that would help me. Okay, and if I multiply 27 times 9, I get 243, and then this is actually has a 5th root, and that would just be 3. So if I do 3 times 3 times 3 times 3, 5 times, I get 243. Remember to enter that in your calculator. You would do 243 caret 1/5 in parentheses. Okay? Alright, now let's do one that's a fraction. So I have the cube root of 192 divided by the cube root of 3. Same thing again. Both of these will give me decimal answers, but if I put them together and actually divide them out, I would get 64, which does have a perfect cube root, and that would be 4. Okay, now what we're going to do is we're going to learn how to simplify radicals that aren't square roots. Okay, so we want to write them in simplest form. Sometimes the directions say that too. So I want to start with just a square root, because you've been doing this since your freshman year, simplifying the radical. So you're going to find the largest perfect square that goes into 75, and that's 25. And so 25 times 3 would give me 75. Then you can take the square root of 25. I'm going to break them apart. The square root of 25 is 5. So the final answer in simplest form would be 5 square roots of 3. Now this is one you've been doing for a while, but so you want to use the same thinking process here. Now I want to think of a number to the 5th power that goes into 128. Now these numbers have to be small, like 2 to the 5th power grows quickly. So 2 to the 5th power is 32. And I'm going to see if 32 goes into 128 evenly, and it does. 32 times 4. So when you're working these out, start with 2 and 3, because they're usually pretty small numbers. Separate these apart, just like you did with the square root. root of 32 is 2, so I can bring that 2 out. Alright, so we need to do a little bit more on this video. Now, I want to teach you how to add these kind of radicals together or subtract them. You can do the same thing with subtraction. Okay, if it told us to simplify this, these are exactly alike. They're both the 4th root of 6, and they have to be exactly alike to add them together. These are like terms, so I can just add the 6 plus the 2 to get 8 4th roots of 6. These are like terms, so just like always, you can only add together like terms. With radicals, they have to be exactly alike. So let's look at one that isn't. And you'll have one like this in your homework, I believe. These are not exactly alike. They're both the 4th root, but one is 48 and one is 3. So what I want to do is see if I can simplify. I'm just going to take the 4th root of 48 and see if I can simplify it. Okay, I'm going to start with 2 again. 2 to the 4th power is 16, and I know that 16 goes into 48 3 times. So I'm going to break this apart. The 4th root of 16 is 2. So this part right here simplifies to this. Okay, so now I'm going to sub that in. Now I can subtract these because they are like terms now. 2 minus, remember there's a 1 right here. 2 minus 1 would just give me 1 4th roots of 3, and that's the final answer to that problem. Okay, end of this part.